Good morning. I don't know which talk everybody went to before, but hopefully you enjoyed it, and hopefully this one will also be enjoyable. So, this is a talk about performance and user experience, and how those two are tied together, and where we fit into the role of making sure that our users are happy. So, my name is Davey Shafik. If you don't know me, I am the author of the Zen PHP 5 Certification Study Guide, as well as the Upgrading to PHP 7 mini book that O'Reilly will be giving away later today. So go check that out. I'm a contributor to Zen Frameworks 1 and 2, PHP Docs. I'm now kind of a legit contributor to PHP internals. I have an RFC that passed. It's great. I'm the original creator of Faro PHP Archive. I'm probably most well known for that. But most importantly, I'm at dshafik on Twitter. So if you have any feedback, any questions, that's the best way to reach me. I work for these guys, Akamai. Who's heard of Akamai? Yay. So for those who don't know, we are a CDN. Primarily, we carry about 30% of the internet's traffic. It's kind of amazing. Go check out our APIs at developer.akamai.com. And also, I always mention Prompt. It's an initiative to get people talking about mental health and technology. So check that out, mhprompt.org. All right, so why does performance matter? Why should we care? So there's been some amazing case studies about this. Amazon, they found out that they lose 1% of revenue for every 100 milliseconds slower they load, which for 2014 equates to about £615 million, which I think is an incredibly huge number. It's about 8p for every person on Earth, or £9.59 for every citizen in the UK. That's just for 2014, and that's every 100 milliseconds. Google found that if their searches were half a second slower, they got 20% less searches. Bing, nobody really cares about, but this number's also quite interesting. 2 seconds slower, they lost 4.3% of revenue per user. The magazine, GQ, they went the other way. They actually cut load time by 80%. And they found that not only did traffic go up by 80%, but people spent 32% more time on their site, which when you're talking about ads is fantastic. I have a bunch more examples, just really quickly. Walmart found that a 1-second improvement led to 2% increase in conversions. Etsy, they went the other way. They found that with 160 kilobytes more imagery on their mobile site, they had a 12% increase in bounce rate, which means that people were more likely to leave immediately by 12%. Staples, 1-second improvement, a 10% increase in conversions. So what can we conclude about this? Number one, users can perceive tiny changes in performance. And actually, I say as little as 100 milliseconds, but apparently that number is actually 14 milliseconds. And slower sites make customers less happy. Less happy means a poor user experience. Now, I don't know if you guys have noticed, but every single slide that I put up here has been 100 milliseconds slower to come up than one before. Anybody notice they've been getting slower? When did you notice? Because I noticed it about 6 slides in, and then I noticed it every frickin' slide after that. That last transition was 2.3 seconds. So the old idiom that 10 seconds is the kind of top bar we want to aim for, that's way too high this day and age. The stats say that for mobile users, it's actually about 2.5 to 3 seconds. After that, they're gone, which is incredible when you consider that in the mobile space, we're on less reliable connections as well. They're even less forgiving. So, I promise no more slow transitions. Who is responsible for performance? And the answer is absolutely everybody. That means your designers, sysadmins, DevOps, back-end developers, front-end developers, and also browser vendors play a huge role in performance. So we have to kind of see this whole picture when we come to making our users happy. So let's talk about what makes a web page today. You're probably not surprised that the majority of a page weight is images, and this number's been going up quite a lot over the last few years. So 63% of a pretty standard web page is made up of image data. Another big one is 17% for JavaScript. HTML and CSS, 3% each. Fonts, 5%, which would also include things like Font Awesome for icon fonts. Okay, so those do play into it. And then I'm not actually sure what the other is, but it's still quite a big chunk. I think just as importantly, the actual weight in megabytes. Let me see what that's. 64% of pages are over 1 megabyte. And 3% are over 6 megabyte, which is huge, right? The number of total requests per page is also going up over time. There are 89% of websites make over 26 requests, the average here being 51 to 75. That's a huge number of requests. I don't think that we put quite enough thought into just how many requests we have to open to load up a web page, and whether that is loading in JavaScript libraries, CSS libraries, etc., but it's also things like iframes for ads, etc. These all add a huge amount of overhead. And in fact, 15% make over 150 requests just to load a web page. So how do we fix this? So starting with designers, this one's pretty simple. Compress your images, and if you don't, see if this works. We'll do it for you. We don't care, do we? Just as small as possible. We don't care what it actually looks like. And we'll actually get into compression a little bit later. Who here considers himself a sysadmin or a DevOps? Some of you? Do yourselves a favor and enable HTTP2. It's supported now by Apache really well. Nginx has support, does not support server push, which we'll also talk about a little bit later. There are also some fantastic proxies like H2O, Caddy, and a few others that you can sit in front of your regular HTTP server. HTTP2 is transformative, and we'll look at that also a little bit later. However, to use HTTP2, you also have to use TLS. There is no browser currently on the market, and there will not be, that supports HTTP2 without the requirement for it to be secure. So let's go ahead. Check out let'sencrypt.org. They provide free, as in beer, fully legit TLS certificates. They're automatic. They have an API to manage those. They're secure. They're using the latest standards. They have transparency. Every single certificate that is registered, there's a register that you can go and look at and see all the certificates that are issued. It's a completely open thing, and it's a cooperative thing. It's being sponsored by Akamai, but also Mozilla, EFF, and a huge group of other companies that are sponsoring this. The certificates are issued for 90 days apiece. You just have your automation renew certificates every 90 days. And there is a security aspect behind that 90-day number. So let'sencrypt.org, go check it out. If you're using the cloud, and I think a lot of us are, you need to start thinking about scaling based on perceived performance. Typically, we would look at our resource usage. How much CPU do we have free on a box or on all of our boxes? How much memory do we have free? And we would scale based on some arbitrary set of numbers. But there's actually a more important story to be told there, which is your users, how do they feel about how fast it's loading? To them, how fast is it loading? So there is something called a speed index, which allows you to kind of get a metric on how fast a page loads for a user. I'm not suggesting that you use it as the only metric to scale, but it is a nice one to add to your metrics checking, and maybe start scaling based around that. So there's a fantastic Node package called Web Page Test API. So I have a little script here, just to kind of show you how easy this is. I will zoom in. To use this, if everyone here familiar with JavaScript Node stuff? Should be fairly easy. So just pull in the web page test module and HTTP, because we need to make some HTTP requests. We initiate an instance of the web page test object, I guess it is in JavaScript, and we call this run test. So obviously, I'm going to run this on my blog. I tell it I want the page speed, and then we have a callback. And what this does is the API immediately responds with the location of where the test results are going to be, and then we have to poll until it is done checking for results. So we have this check response, and it will check the API that it tells us the results are at. So this is what check response looks like. It takes the URL, and then it does a simple get on it, and we have another callback with the response. I really don't like the way Node's HTTP client works. Essentially, as data comes in, you have to assign it somewhere. So it basically works really well for chunked data. But as it comes in, we have this callback here, which just assigned it to this response data variable. And then once we've got all of it, once we hit the end of the data, then we can actually pass it as JSON. If we get a status code of 200, as opposed to, say, a 201 or something else where it's in progress, then we can actually get the information out of it of how fast did it load the very first time somebody loaded the page, so with no cache, and also how fast does it load if they do have caching. So those are two very important numbers. Otherwise, we just have a set timeout for 5 seconds, and it will then check again. So what this actually looks like, we run it. Test result is at this URL. Test just started. And these are actually exactly the responses from the API. It will actually tell you that information. And as you can see, we have a speed index of 4296 on first load and 3109 on second load. That's good because it tells us that we do have some caching enabled. But it's really a relative number that you're going to be looking for. So you check, are you happy with it? OK, that's the number we're going to aim for. And you can just start to inform your scaling metrics with that. All right, so back-end developers. I suspect the majority of people fall into this category. This is probably not a new idea, cache aggressively. So database caching, we have multiple levels of caching. Database caching, whether that's Memcache, Cassandra, doesn't really matter. Put something in place. Full-page caching. This is much more difficult, I find. So whether you're using Memcache, Cassandra, Varnish, Squid, some sort of reverse proxy, we run into this problem with authenticated users. We also have things like geographically based caches. So for example, if you have a web property that serves to the entirety of the world, you may have different types of sales going on for different parts of the world. Maybe you have just different messaging, different languages, all these kind of things. These all play into the difficulties of full-page caching. So we start to look at something called Edgeside Includes, or ESIs. Has anyone run into this before? OK, so Edgeside Includes are really cool. They are supported by Varnish, Squid, and a few others. They were actually created primarily by Akamai, and we, in my opinion, have the best support for them. Edgeside Includes are special HTML tags that allow you to inform the cache about small sections of your page, so that you can say, I want to cache this little fragment differently to other parts of the page. So whether that's based, you can say, I don't want any caching for this. You can set a different TTL. You can make it per user session, which is really important for logged in users. So you can still cache everything until it needs to be changed, but it's specific for the user. You can also do it for things like geographic area. So as I mentioned earlier, where you have different content for different geographic locations, you can actually use Edgeside Includes to cache all of those differently. It's very cool. So this is what it looks like. So we have this ESI include tag. So this is what you want to cache. You can set some other attributes in here to change the caching and stuff. With Varnish, it's basically set in the config. And then we have essentially a fallback. So this is just a piece of PHP code that will run on the server, like as a page is rendered normally. And it has some sort of fallback that you want to be able to show if Edgeside includes are not supported. Or maybe the proxy server that's going through falls over and it can't process them right now. So I'll just go back. So this one is the server is going to include this. So it'll actually make a sub request and include that content. This one is rendered inline and will be removed if the Edgeside include can be successfully run. So you have some sort of fallback there. OK. Any questions so far? Great. So the next thing I want to talk about, I mentioned image compression, and I said your designers need to do it, otherwise we're going to do it and probably get it wrong. But we can actually do some really amazing things with image compression when we talk about looking at it dynamically. So the first one, probably the simplest one, is format negotiation. I think most of us probably know that certain image formats lend themselves to certain image contents, and that you get better compression. So for example, if you have an image that has maybe under 12 colors, a GIF will typically give you better compression than PNG 8, even though they have the same 256-bit palette normally. That just is a quirk of the compression. But generally, PNG 8 will give you more compression. JPEGs, better for pictures. PNG 24 will give you better fidelity, but higher image sizes, things like that. There are two new formats that are kind of coming out. There's WebP, which is supported by Chrome, and JPEG XR, which is a new JPEG standard, which is supported by IE 9, 10, 11, and Edge. We can actually check and store different versions of an image in different formats and serve it depending on the browser that's coming in. There is nothing to say that just because the file was uploaded as a JPEG, that it should stay as a JPEG. You should be doing things like double-checking in different formats and different compression levels. how small can you get that image and how can you serve it? And there are other things we can do as well, like responsive imagery, making sure that we're not serving ginormous pictures to mobile phones, things like that as well. So compression is a huge part of this. So not just formats, but actually how we compress it within formats. One thing I ran into while doing this, JPEG levels. I always assumed they were a % or something like that, or like the gzip-9, that's -9 is the most. That's actually not true. They're actually kind of arbitrary. The JPEG encoder itself actually decides what that means in the context of its compressor. So they're not consistent. That image I showed earlier, I don't know if you're able to see how crappy it looked. I actually couldn't get that in Photoshop. I took it all the way down to 0, and it still looked fine to me. I had to shrink it down to like 250 pixels and then back up to like 5,000 to make it look like crap. Those numbers are a little bit weird, but they're kind of one of the things we get to classify stuff on. So you'll see that. So what I want to talk about is something called perceived quality. We mentioned earlier about kind of the perceived page load time. You also have a thing called perceived quality. So this is quality that we can see with the naked eye. This is not just looking at image sizes. This is not just looking at, we're not using sort of data recognition, image capture type stuff. We're just talking about what can humans see when they look at an image. So here is that image I showed earlier in full. Here's the terribly compressed version. Now, we obviously can tell that's horrible. So this is the original again, 16.8 megabytes. It's quite large. This is like a 5,000 pixel image or something. Obviously wouldn't serve it unless you were Flickr. Maybe you would serve it there. But if we take it down to 90, whatever that 90 is, it drops by almost 2/3. And yet it looks, and I know it's on Objective, it's kind of hard to see, but it looks pretty much the same. 80 will take us down to 4.2 megabytes, 70, 60, all the way down to 0. So we go from 15.4 megabytes to 393 kilobytes. And in my opinion, that looks just as good as the original. So there's the original. There's 0. Now you can kind of see a difference. We'll look at, that's actually full size now. If you look, it's not really clear here, you can kind of see a little bit of sort of JPEG artifacts coming in the bottom. The grass is not quite as clear, things like that. But actually, Photoshop has an amazing compressor, apparently. Not a great thing to use for an example. So when we talk about perceived quality, how can we programmatically determine what that looks like? So we have this wonderful thing called structural similarity for images, SSIM. And it's actually an Emmy award-winning algorithm. I'm not sure who collects that or how they present it. But this algorithm, which I'm not going to explain because I don't understand it, was given an Emmy, and it's used very often in film, video. And what the SSIM algorithm does is it looks at 3 very important things. And I mean important as far as humans are concerned. It looks at the brightness of an image, the contrast in an image, and the structure of an image. And most importantly for us, it's really fast. So we also have something called DSSIM. So while you can calculate the SSIM score for an image, DSSIM is actually more important to us. This is the distance between 2 images as far as their quality. So we can take the original image, we can compress it into different levels, and then we can compare how close would the human eye perceive it to the original. So let's see if this works. So this is basically it's generated a heat map that is generated by how different the image is from the original. So we'll start back at 90, so it's 0.09. These numbers are actually just 0 based and go on to infinity. It is a kind of a relative measurement. But as you can see, the lower the compression, the more noise we get, and the further away it is from the original. So what you're going to do with these numbers is you're going to set a threshold. You're going to say that I want images to be within 0.02 of the original. Anything below that I'm happy with as far as compression. Let's see how far we can compress it and how small we can get it before we think our users will actually notice that the compression is coming in. Did anyone see, I think it was about 9 months ago, Flickr changed their compression algorithm, or their compression amount, and there was a huge uproar because Twitter, Facebook, Flickr, one of them, Flickr had actually done testing and actually said, can you see the difference? They actually had people go and they had side-by-side images, which one looks better? And then they chose the algorithm based on that. So they'd done the tests. But when they rolled it out, they found out that people could actually see the difference. And they complained. Now, you're talking about photographers, people that pixel peep their images all the time. But they noticed. And so they actually rolled it back and then rolled out a slightly less aggressive compression. So say we do decide on a 0.02 threshold. We can actually look at these numbers and we can see that we get all the way down to 30, whatever that represents in the JPEG compression, before we hit past that 0.02 threshold. So we know that we can compress all the way down for that specific image, all the way down to the level of 30. So I don't know about you. Whenever I sort of take a JPEG out of Photoshop, I try 80, I try 60, I go back to 80, and then I save it. I'm like, it's 1.2 megs. I've got 75 megabit at home. It's fine. We don't care. But doing this programmatically means that we can apply it consistently across all of our images, and we also don't have to care about the content of those images before they go up. So while I said our designers should be compressing, they absolutely should be, even if that just means that your deploys are smaller, applying this sort of thing at runtime can be pretty fantastic. What's nice is you always have the original, so you can serve the original while you're doing all the different levels of compression, changing formats and all these kind of things. And then, obviously, once you've got something better, then start serving that. So, as I said, you want to set a threshold. So let's just take a quick look. The original 14.1 megabytes, that's actually not the original. I sized it down just a little. 80, so 0.08 difference, 4.6 megabytes. 50, 0.012, and then there's that magical 30 at 0.174. As far as the eye were concerned, if you were seeing these on a display, full size, you probably wouldn't be able to tell the difference between these two at all. And it saved us 91.4% of our bandwidth, our size, which is kind of an incredible saving. All right, so how many front-end people do we have? Right. I think that there is not enough credit given to front-end anymore. This plays a huge role in performance, and there is some really, really cool stuff coming and sort of rolling out now. And the number one thing is known as predictive browsing, or pre-browsing for short. And this is, in my opinion, the coolest thing in this talk. Not just because I have awesomely animated slides coming up. So, there are 4 different types of pre-browsing. There is DNS Prefetching, where we can tell the browser, hey, we know we're going to load something from this domain next, so go ahead and do the DNS lookup. There's TCP Preconnect, which says, hey, we know we're definitely going to load something from this server, so go ahead and connect to it. There's Prefetching, which is go grab the content, and then there's pre-rendering, where it will actually grab the content, all of the resources necessary to render it, and render it off screen. And as soon as they click the link to go to it, it would be immediately popped up. So how does this look? So as I mentioned, we start off with a DNS prefetch. Then we open up our TCP connection to the server. We preload it, so we go grab the content, we just hold it in memory, we don't do anything with it, we don't parse it, we don't get any sub-resources. And then finally, we do pre-render, where we actually do the work of rendering it. So to do this, these are all really similar. It's basically a link tag in your head. So inside your head, link rel equals DNS prefetch. You'll notice we don't have a protocol here. We don't need it to do a DNS lookup, so why include it? Preconnect, very similar, except rel equals preconnect. This time we have a protocol because we need to open up to a specific port. You would also want to put a port in if you had some non-standard one. Prefetch, rel equals prefetch. Page URL, that could be relative or absolute. And pre-render is exactly the same except pre-render. I will caution you about this one. This one seems like the best one. But remember all these graphs about how heavy pages are? All of this does have to happen to pre-render. So you're actually now causing contentions between your current page and the next page. There is another standard that is, I almost say standard, it's a working draft, that is coming along called rel equals preload, which sounds very similar to prefetch, and it kind of is. The difference between preload and actually all of the pre-browsing stuff is pre-browsing is based on what's coming next. what is the next action that the user is going to take, whereas preload is, and it's optional, and it's low priority. So that's something to keep in mind for all of the pre-browsing stuff. Preload, however, is meant to be mandatory, and it's for the current action. So for example, you can say, I want to preload my fonts. So normally, you load the HTML page, it gets passed, it sees the link for the CSS, it pulls the CSS in, it passes all of that, sees a link to an image or a font, and then makes another request. You could put a link prefetch to that font, and preload to that font, and it would pull it before it's finished passing the CSS. Okay. So you can get really granular about this stuff. Preload is also typically sent as a header, because it's meant for the current page. So what's really cool about that is, as I mentioned, you could say pull in fonts. You could also say, hey, here's the HTML page, and by the way, you're going to need this CSS, this JavaScript, these fonts, and all this other stuff to render this page. So they don't have to retrieve the whole thing, and they don't have to pass it before they know all that information. They can start making requests immediately. So you can just trim off just a little bit of time at the start there. So I think with all the new stuff that's coming, we're going to start to see some new architectures around how we serve web content. And it's all sort of predicated on this, which is that HTTP1 sucks. We have come up with some fantastic technologies, things, I don't know what to call them. So for example, minifying and concatenating JavaScript and CSS files. Inlining very small bits of JavaScript and CSS for our critical path. Does everyone know what critical path means? Essentially, it's the idea that we only need to render what's visible on the screen when they first load the page. That's the thing that has to be there immediately. So what we'll do is we'll take a very small subset of CSS and a very small subset of JavaScript that's necessary to render just that, and we'll actually inline it rather than having it be a separate request that takes time. Image sprites, data URIs, domain sharding, these are all techniques that we've come up with to improve the performance of HTTP1 within the limitations of it. Browsers will only allow load 6 to 8 things on any single URL, so we shard across domains, these kind of things. Quite frankly, all of these things are hacks, very clever hacks. They've done amazing things, but they are all hacks. So HTTP2 is coming. It's supported right now by 60% of browsers out there in the world. As I mentioned, if you're a sysadmin or a DevOps, you should be enabling HTTP2. It's pretty fantastic. It has this idea of multiplexing, which is that you can use one connection for parallel requests, and you can send as many requests along that connection as you want. You no longer have that 6 or 8 connection limit. So if you're doing domain sharding, you can actually hurt yourself in HTTP2. We also have something called server push, which is this idea of the server being able to inform the browser, hey, here's something you're going to need, go ahead and download it. And it's actually semantically the same as the preloading that we had, except instead of a header, it's actually just another stream inside of the HTTP2 connection that says, hey, here's something you're going to need. So server push is pretty amazing as well. And all of this happens inside of one TCP connection. With server push, we no longer need concatenation because we no longer have separate requests. We no longer need to do compression because we've got gzip compression. It's good enough. We no longer need to do inlining because we can actually send those small subsets as separate documents. So semantically, they are separate, but they don't need to be inlined anymore. So let's take a look at what it means to deliver a page. Open up TCP connection, do a GET request, we get a response, right? This is pretty standard. With server push now, we can push the critical path CSS JavaScript, and maybe we push our logo because we're vain. We can also do things like set up what's known as a parent, so a, what's the word? A requirement. So you can say, I want to send my CSS immediately, and as soon as it's been sent, but not before, I want to send the font. Same with your main JavaScript. So as soon as your critical path JavaScript is loaded, follow it with the main JavaScript. Maybe have some sort of splash image that'll follow the logo. And then we want our main CSS to follow the font. So when we load the page, we're going to load the critical path, which will just set up sort of the layout for everything that's visible in the viewport. We will send the font so that all of that in the header will load correctly, and then we'll send the rest of the CSS for the rest of the page that they can't see yet. Okay? So this is what's known as the critical path. So, in summary, performance really does matter. There's a great website, wpostats.org, maybe .com, which lists a whole bunch of use cases. All the ones I've cited earlier are from that site. If you need to convince your boss, your manager, team lead, that this stuff matters, show him the site. Go find use cases that match your particular pattern. This is why we need to do this. As we know, time equals money. And we also know that time equals user satisfaction. We know that our users hate slow pages. We know it ourselves, but we've never really quantified it. So performance is user experience. So if you would love to rate me on Joined In, I would very much appreciate that, any feedback you have. As I mentioned, I am at dshafik on Twitter, dshafik@akamai.com if you would like to email me, but Twitter's pretty much more immediate. I'd certainly prefer it. And then these slides will be up at daveyshafik.com/slides as soon as I can upload a 300 megabyte PDF. The original slide deck is like 750 megs. So any questions? Yes. Oh, wait, there's a mic.
The pre-render thing you were mentioning, does that affect ad impressions as well?
It would be exactly the same as any other request. They should be doing some sort of detection to see, like, is there a mouse cursor or something? Like, there are ways they can detect it on the back end, but in theory, it is just a browser request.
Google Analytics as well, so would that artificially inflate?
Potentially.
Yeah.
But you do have to weigh it against the fact that you are using resources that aren't necessary and potentially being contentious with those resources. Any other questions? This one here, so one in the back. Oh, him down there as well.
So you said before that compress your images, or we would do it for you. Does Akamai has some service to force compressing images?
Akamai has an amazing service for compressing images. All of the technology that I covered, we do have automated services for that. So whether that's format interchanging automatically, obviously it's all cached on the edge, so that makes a big deal. But yes, we do have a service for that. It's called Image Manager.
Okay, so I understand that I, as a user of Akamai services, have some settings to set, I don't know, the scale, how the images should be compressed.
Yes, you can set the threshold.
So this is about this is using this metric as you.
Yes, it's not. So the tool that I use is a tool called DSSIM. It's completely free, open source. It did segfault on my Mac. I had to do it inside of a Docker container to get it to run. But it is completely free and open source. It's similar. We have our own implementation. But yes, the same kind of metric, the same, or at least this is one of our metrics, is the SSIM algorithm. Paul had something.
Hi. Question about the prefetching and pre-rendering, whatever. I'm trying to think in my head a scenario where I would use that. And I was wondering if you could give a good example. The example I could think of was you're on like a checkout page and you can predict the exact step they're going to next. And I thought, okay, that's a good example. But I'm wondering if there's other examples where you could say, you know, you have sites that work as is right now. Coming over to HTTP2, what kind of scenarios would we find as developers to start looking, oh, this is an opportunity where we could use prefetching rather than just guessing, and oh, this is a cool idea, let's introduce it?
So there's kind of two parts to this. One is we kind of have an idea in our heads when we design user experience what the flow will be like for a page. So, for example, if you go to Google, they know that probably the next thing you're going to do is to click the Go button to search, right? Now, obviously, they can't preload that, but what they can do is they can preload page 2 of the search results, right? So we do kind of have an idea of what our users do. I think better than that is actually looking at our logs and tracking what users do. We get all these metrics through things like Google Analytics, and we can actually then make predictive analyses of where they're going to go next. And we can actually in real time modify what we're preloading based on that. And then as far as the other side of that, which is things like server push and preload, where you're actually doing it for the current page, it is going to be all sub-resources. You just got to make sure that you prioritize them right. So do you care most about the font coming in or about your splash image? I do have a whole nother talk on HTTP2, so I'm not giving it here, but like there is a whole talk around that. So I hope that answers at least some of your question.
About server push, will it replace the way that we're currently doing Ajaxing, i.e. like if we're polling for stuff, because the client has to say to the server, you do have stuff for me, whereas you're saying now server's informing the client?
Yes and no. So it doesn't in that, two things. Server push is not something that the server can say to the browser, you're taking this and you have to like it. The browser can reject server pushes. And basically what happens is the server says, hey, I've got this thing I want to send to you. Here's some headers. Decide whether you want it or not. And then it will take it. And essentially it actually sends both the response and the request that would have elicited that response. And it's cached so that when they then make the request, it then gets pulled out of the cache instead. So it actually is just pre-caching rather than sending it to, there's no like JavaScript event or anything that happens on the front end. So it doesn't replace Ajax in terms of like push. It would just make it a lot faster because we could send it to them, and as soon as they request it, they've already got it in the cache. So there was another question, I think, way in the back. Oh, two.
Hello. Just in terms of HTTP2, can you give me some more compelling reasons why you wouldn't do the upgrade? Because it sounds great, and I'm ready to press the button, but just some other edge cases. Say I'm running Apache or Nginx, which is kind of already supported-ish. Yeah, if you can elaborate on maybe why you wouldn't do it yet.
Number one is that you do have to have TLS. There is some overhead there. Number two is, in some cases, which is the I'm pulling one thing, one page, and there's no sub-resources case, HTTP2 is slower because there's a handshake that has to happen. So the way that HTTP2 works and the way that it's backwards compatible is there's two ways to upgrade. If it were in plain text, it would send an HTTP1 request and say, hey, I want to upgrade. The server says, OK, that's good. Let's do this. And the connection will switch. No idea what happened there. The other one, which is with TLS, where it actually does it in the TLS negotiation, that does add a little bit of overhead, but it's better than opening up multiple TLS connections. So if you do have a page, and most of us do, that has CSS and JavaScript and everything in there, and using one connection for all of those would be great. So is there a reason not to do it? Potentially infrastructure reasons. You know, I do think that Nginx support is very, very early. Doesn't support server push specifically right now. They just put it in there. Apache, if anyone's still using it, they're using a library called NGHTTP2, which is also the one that I'm thinking to use in PHP. It's a really mature, solid library. It's quite heavy, though. So go and test. For the most part, for your applications, it's completely transparent. Until you get into things like server pushing and whatnot, which is initiated by headers, which is great. It means that all the languages that can do HTTP can already do server push. It's all handled at the HTTP layer. Just go for it. Try it out. I mean, put it on your staging infrastructure and check it out. There was someone there, and then there's the guys.
I was just gonna. Sorry. I was just gonna ask something about like backend versus frontend. Right now, I've heard like rumors in the dark internet that people have been starting to make decompression engines on the frontend side, and I was just gonna ask you about what's your point on that? I mean,
decompression engines?
Yeah, decompression
so
engines. Because I mean, since Vulkan API just released, and that's a like huge cool thing, and I expect that there will be a JavaScript support for that. We suddenly just got like a Ferrari in our web browser with just decompression speed. But is that really a good idea to like force the clients to decompress everything, even if it's like super fast?
Honestly, I don't really understand the question because I've not looked at that at all. Okay. That's going to be my answer. So we'll talk about it after. Maybe that'll be a new slide next time I give it. Here.
It was just, you talked about the prefetching and you showed the syntax for how to declare which resources you want to be prefetched.
Yes.
Just which browsers are actually, how many browsers are supporting this now out in the wild?
Prefetch or preload?
Well, both actually. It'd be interesting.
Essentially, Chrome is the leader in this whole thing. Firefox has support for some of it. Safari, I don't believe, has any support, and IE isn't quite there yet. The nice thing is they are all backwards compatible, so they can be progressive enhancements. Server push is supported by, again, I think Firefox and Google, and Chrome, and I think also WebKit. But yeah, because it is a progressive enhancement, you can start to do these things now. Also, in my HTTP2 talk, I also talk about how we're not just talking about browsers, we're also talking about API clients as well. The patch that I have in for 7.1 gives server push support for curl, so we can now start to do it programmatically as well, which is pretty cool. Right, now we can go to the gentleman in the middle-ish. Yeah.
Thanks. Yeah, a follow-up question from that one. Where browsers don't support prefetch, what do they do? Do they go and get the resource there and then and slow things down, or does it just do nothing?
Yes, essentially they do nothing, or rather, it lends nothing to the process. It just falls back. So, any other questions? Yes.
Yeah. Hi there. Over.
I see.
Hi. Isn't the problem with HTTP2 support not a patch in Nginx, but the fact there's a severe lack of CDN support, and setting up TLS in CDNs is just a faff?
So Akamai supports it. We have for a long time. I know Cloudflare just added it. I believe Fastly is getting there. It certainly is coming along. Akamai being the largest CDN, I mean, that's the only one I care about.
You got your T-shirt on.
But no, I know, so a big one is Amazon. Amazon CloudFront does not support HTTP2, and they have not put it on their roadmap. As a company that builds CDNs, the reason that we, Mark Nottingham, the lead of the HTTP2 working group, is an Akamai employee. The reason that we have put so much resources and the reason that we love HTTP2 is it's good for us and it's good for our customers. It saves us money, it saves us resources, and it makes things faster for our customers. It would be insane for Amazon not to add it. I just think they're not ready to commit. So it will come. Anything else? Yes. Hang on, mic is good.
Just a very quick one about DSSIM.
Mm-hmm.
When you're calculating the difference between when they're calculating the difference between the images, do they account for the human eye perceiving several groups of colors as the same? So when you calculate a difference, it's not necessarily different.
So as I said, I don't know how the algorithm works.
Okay.
What they're looking for is brightness, contrast, and structure. I believe that the contrast one is where that comes into play. So yes. I'm hoping. It is a really good, I mean, it really does work. When you look at the results yourself, you do really start to see, okay, I can see a tiny bit of difference here, but it doesn't matter. And then the next one, you're like, oh, yes, that obviously is different. We have more, yes, and we have one in front as well after.
Hi there. About HTTP2.
Yes.
Could you expect to see any performance benefits out of the box, or only if you start implementing some of these features?
You should see performance benefits out of the box so long as you do have that not a single request scenario. So long as you do have style sheets and JavaScript and stuff like that, you should immediately see performance benefits.
Okay, so some of the parallelism just happens for free.
I'm sorry, say again?
Some of those parallel request things happen for free?
Yes, they do happen for free. The browsers will do that for you. And as I mentioned, 60% of browsers currently in users' hands, not just the ones that are released, do support HTTP2. We had in the front here, do we have a mic? Yeah.
I was just thinking about the security implications of server pushes.
About what, sorry?
Security implications.
Security implications of
server push.
Of server push.
Yeah.
It's all within the same, it's on the same connections that's already opened, all the TLS has happened. There really isn't any. It is exactly the same as the browser making the request, and then they do get the chance to deny it as well. It happens in the same rules as what can happen on a connection. You can do, for example, see if I can get this right. In theory, because you can have one TCP connection to two different, it's the same machine but two different host names that have the same SSL certificate. In theory, you could have another thing behind a load balancer pushing something out, but it's still the same connection. You can't just randomly push to a browser. They have to have initiated the original connection as well. So there really isn't any security implications there.
Yeah, but there can also be the case in which you trust a website, and then all of a sudden, something nasty happens.
So it's not push like push notifications. You have to be within a HTTP transaction already. So you have to have opened the initial thing. You have to have made some sort of request before they can start pushing to you. So it's not like you're browsing along somewhere else and something you visited last week sends something to you. It is just that sort of current session. So, any other questions? No more? I think there's one over here. I'm not going to hear you from there. You've got to wait for the mic.
I was just also thinking in the context of the preload and prefetch that basically you are serving lots of, well, not necessarily lots, you are serving content from the server to the browsers that may or may not really be needed.
Yes.
So have you got any benchmarks with regards to, you know, how much, let's say, resources you are spending sending content that the user doesn't really use?
So I think that this, it's a very important thing to consider. It is a cost to benefit ratio that you're going to have to determine for yourself. How much money are you willing to lose on bandwidth for stuff that never gets used? How much of the user's bandwidth are you going to use? Bearing in mind, if they're mobile and they have limited data, or if they have data caps, you could potentially be impacting them financially. Again, this is one of those looking at common trends and basing what you're preloading and pushing and fetching, all that sort of stuff, based on current trends. Also based on, are they on mobile? Okay, probably we shouldn't be pushing this 8 megabyte JPEG down to them. So it is definitely a trade-off. There is definitely the potential for waste. Hopefully you're just a little bit judicious about how you use it. There are some things, though, that are very obvious. So the CSS for the current page, they probably want that. Like, there are some very obvious ones. It's that when you get into the next action type stuff that you're not sure. So, yeah, it's definitely something you're going to have to decide for yourself.
Yeah, I wasn't necessarily speaking about the bandwidth. I was also talking about, you know, the cost on the server side to actually generate the resources.
That technically also comes down to budget, right? Because, I mean, you're using resources, how much, whether that's financial resources or server resources, you need to decide what you're comfortable with spending.
So the short answer to the question is no, we don't have any benchmarks.
No, we don't have any benchmarks. That is a very short answer. Yes, we don't have any benchmarks because it is still so new. I do know that as a CDN, we do use those hints to preload our CDN as well. So that's one of the things that we do. So it's not just your end users that are benefiting. Also, it is your CDN infrastructure. They can preload stuff, and then they have it on their edge for your users as well when they need it. So that actually could save you resources because you're offloading more from your origin. Any other questions? What time are we at?
Yeah, great talk, thanks. I'm sorry, it's another HTTP2 question.
That's fine. I asked Joanna to give me an HTTP2 talk, but there is an HTTP2 talk happening. I think Ben Ramsey maybe is giving one here. So go to that. Carry on.
Cool. You said that a couple of times that TLS is required to do HTTP2.
Yes.
Is it possible in Apache, say, to configure so that I use TLS with the HTTP2 connection, but if I get a sort of old school HTTP1 connection, then I can do it plain text? The reason I ask is that I know this shouldn't matter, but the Let's Encrypt certificates don't work on Windows XP.
Yes.
And that's
the
been a
answer
problem
is yes,
for us
you can do that.
Cool. Brilliant.
The HTTP2 stuff, HTTP1 are completely backwards compatible. Within Apache, it's sort of a, which route is it going kind of thing. Yes, you can do that. You don't have to use Let's Encrypt, of course. But also, it's only the browser vendors that are making HTTP2 require TLS. Curl does not require it, and potentially any other non-browser may not require TLS. Frankly, there's a website, is tlsfastenough.org or something, and the answer now is yes. We should just encrypt everything, so let's do so.
Thanks.
Anything else? Yes, there is. No? All right, well, thank you very much.